Climate Change, published on April 28, 2018, by James Eyre. April 28, 2018, by James Eyre. As the ice sheets of the world melt, an enormous amount of pressure will be lifted off of the continental crusts that play host to them, as well as the surrounding oceanic basins. Something similar is broadly true, but to a much lesser degree, of the world's remaining large glaciers. Think of the Himalayas. As this pressure is lifted, after tens of millions of years of being there, tectonic and volcanic features that have been dormant for hundreds of thousands of years or even tens of millions of years will awake, as will broader geologic system elements and processes. Melt streams on the Greenland ice sheet on July 19, 2015. Ice loss from the Greenland and Antarctic ice sheets as well as alpine glaciers has accelerated in recent decades. NASA photo by Maria Jose Vin. The ice sheets of East Antarctica have effectively been there in one form or other for approximately 15 million years, to a lesser extent than now, though, while a portion of the Greenland ice sheet is thought to have partially melted around 120,000 to 130,000 years ago during the Eemian interglacial period. The volcanic and tectonic pressures of the regions in question, in other words, are now well primed. While all of this may just sound like a horror story or something to some of those reading this, there's a reason for that. A basic sense of highly traumatic natural disasters is encoded culturally, and possibly genetically as well, in people, with stories being the vehicle to bring such awareness to the surface. This is the take of many people, mine included. That basic sense effectively brings with it hundreds or thousands of millennia's worth of human experience of extreme natural disruption and disaster. Hence the relatively common human fascination with them. Think of the way that some but not all people are inherently wary of snakes and spiders, despite the very limited immediate danger they pose. The reality is that the last few thousand years have been almost unbelievably stable by pre-historical standards when it comes to geologic and volcanic events. Looking back across longer stretches of time, one sees what would be considered to be civilization-wrecking natural disasters regularly. One also often sees, of course, oceans with currents, winds, and waves that would effectively make modern-style large-scale oceanic shipping an impossibility. These periods of time often seem to also be host to enormous and powerful storms that do not have modern analogs. But that's mostly neither here nor there with regard to this subject. Though, I will note that as sea levels continue rising, and as ocean temperatures continue rising, the total area of the Earth covered by the oceans will increase, and a greater portion of overall ocean area will relate to shallow areas, which will make the open oceans a much more dangerous place than they are now. Back to the subject at hand, though, I'm going to provide an overview here of the potential volcanic and geologic events awaiting us as the world's ice sheets disappear and the processes buried beneath them wake up. I'm going to do that by doing what reliably throughout human existence has given the best predictions, taking a look at the past, at actual geological history, inferring patterns, and intuitively projecting them out onto the future. Basic points. Image credit. NASA is a reminder of why this matters. It should be realized that the world is now on track for a 3 degrees Celsius to 8 degrees Celsius temperature rise by the year 2100, effectively enough to lead to the complete melting of the West Antarctic and Greenland ice sheets, and possibly the East Antarctic ice sheet as well. As far as the timing of such melting, assuming that the just mentioned range of warming occurs by 2100, it shouldn't be assumed that melting and collapse will occur slowly or evenly. As noted in a 2007 paper co-authored by James Hansen, we find no evidence of millennial lags between forcing and ice sheet response in paleoclimate data. An ice sheet response time of centuries seems probable, and we cannot rule out large changes on decadal timescales once wide-scale surface melt is underway. That's the reality of the situation. Past ice sheet melting processes have played host to catastrophic pulse events, whereby global average sea levels have risen by many tens of feet in just a few years' time. In such cases, pressure changes on tectonic plates and volcanic hotspots would have been severe, leading directly over the shorter midterm to a large uptick in volcanic and tectonic activity, as numerous studies exploring the issue have found. For instance, by 2 to 6 times above background levels from 12,000 years ago to 7,000 years ago into glaciating regions with regard to volcanism. On that note, in the past when this subject has been brought up, I have heard some people argue that such an increase in volcanism would result in global cooling due to the release of reflective compounds into the atmosphere. A look back at geological history, though, shows clearly that this idea is mistaken. Volcanic cooling due to the release of reflective compounds is a very short-term phenomena, whereas greenhouse gas climate forcing plays out over much longer periods of time. To simplify it, greenhouse gases are atmospheric gases, whereas the reflective compounds just discussed are essentially dust, which largely settles. It should be realized here, in relation to that the current widespread burning of fossil fuels itself results in the release of such reflective compounds into the atmosphere. If such burning was to cease completely as of right now, the cooling effect provided by such compounds would disappear over just a few years, while the heating effects provided by the greenhouse gases released to date would continue far into the future. As it stands, the greenhouse effect already greatly eclipses the cooling effect, but with the settling of the reflective compounds, heat gain would amplify quickly, leaving the world in a bit of a catch-22 when it comes to fossil fuel burning. Moving on to the crux of the article. Volcanic events and ice sheet melting has posited the theory that one of the drivers for the relatively rapid shifts from glacial to interglacial time periods, as is often seen in the geologic record, is in fact rising rates of volcanism. The idea is that, as ice sheets melt, the reduced pressure leads to rising rates of volcanism, as can be observed in the record, and this leads to gains in atmospheric greenhouse gas concentrations over the midterm. So, to say it again, over the midterm, rising rates of volcanism leads to rising temperatures, as the cooling effect resulting from the volcanic emission of reflective compounds into the atmosphere is short-lived, whereas the effects of greenhouse gases are much longer-lived. Conversely, that idea includes the assertion that falling rates of volcanism, as interglacials drag on, is a cause of atmospheric greenhouse gas concentrations and temperatures, and thus a return to glacial conditions. Interestingly, the evidence also seems to show that, as temperatures rise, and thus as sea levels rise, from glacial melt, volcanic activity on the seafloor is reduced, owing to the greater weight of the water resting on it. Tectonic activity, on the other hand, is a different matter, as increasing oceanic weights may well intensify the intensity of earthquakes and similar events. To go back to specifics here, there are numerous volcanoes currently active around the peripheries of Antarctica, but what's very interesting is the presence of an extensive volcanic belt beneath the West Antarctic ice sheet, possibly the largest such belt of volcanoes in the world according to a recent study, at least 138 strong, some of which are quite extensive. As noted in that study, West Antarctica is also home to one of the most extensive regions of stretched continental crust on the Earth, so it's not surprising to learn that volcanic and tectonic activity in the region is potentially, periodically, quite high. What's particularly notable to us here right now, though, are the potential effects that such subglacial volcanic and tectonic activity could have on the stability to the nearby ice sheets. It isn't necessary for an ice sheet to completely melt for a large volcano to erupt. After all, partial melting, and thus greatly reduced compression, could well be enough on its own to trigger widespread subglacial volcanic activity in the region. And what would a large increase in volcanic and tectonic activity lead to in the region? Increased ice sheet melt rates, large partial collapse events, sea level rise pulses of several to tens of feet in just a few years' time? To what degree could subglacial volcanic eruptions increase basal ice sheet flow rates? Of course, no one can say for sure on any of those counts as of right now, but it is very notable that there's evidence for numerous large sea level rise pulses throughout prehistory that retain ambiguous origins. The speculations discussed above provide a potential, partial answer. Back to the world of what is known concretely, Antarctica is currently home to at least 4 volcanoes on the mainland, and numerous volcanoes on nearby islands. As would be expected, these active volcanoes are only known of because they are located on the peripheries of the ice sheets, or on outcrops. Whatever volcanoes are present under the vast ice sheets have to be inferred, though they are clearly widespread, with there being at least 138 in just West Antarctica, as noted above. Image by NSF Josh Landis. The 4 active mainland volcanoes are Mount Berlin, Mount Hampton, Mount Melbourne, and Mount Kaufman, 3 stratovolcanoes and a caldera. On the surrounding islands, there are a fair number of active and large volcanoes as well, including Mount Erebus and Deception Island, both of which have been relatively active in recent history. Other island volcanoes known to be active are Penguin Island, Buckle Island, Lindenberg Island, and Pollitt Island. The area around West Antarctica is also known to be home to numerous underwater volcanoes, some of which are located in relatively shallow areas. Evidence for high levels of relatively active volcanoes in the region include pronounced geomagnetic anomalies, evidence of subglacial volcanism, and high regional heat fluxes. That all being the case, those that assume the relative quiet of recent centuries with regard to West Antarctic volcanism will continue indefinitely are likely mistaken. As the ice sheets there continue shedding mass, and thus lowering compression, an increase in activity seems likely. Another aspect to consider while discussing this subject is the presence of large coal deposits and oil shales, dating back to the Devonian and Jurassic periods, mostly around the Transantarctic mountain range. While such a possibility is a low probability event, it still seems worth considering what would happen if these relatively exposed coal seams were to be ignited via volcanism, an event which appears to have happened at numerous times in prehistory in different parts of the world. What we can say for sure, though, is that a volcanic hotspot is located just to the east on the island on Iceland. We can also note that Iceland is known to have experienced an increase in volcanic activity as it deglaciated. Does this imply that something similar will happen in Greenland, but on a much larger scale? No one can say for sure one way or another at this point. Despite that being the case, I'll still note here that, given the bowl-like shape of the island, with the ice sheet held in the center, potential subglacial volcanic eruptions would likely increase the rate at which the ice sheet melts and flows into the sea. Geologic history shows this to be the case in Iceland, and something very similar has been inferred to have happened numerous times in West Antarctica in the past as well. Something that's less up for debate, though, are the effects that the melting of the truly massive ice sheet of Greenland would have on the tectonic stability of the wider region. It's pretty much a given that large tectonic events would follow over the nearer midterm if the ice sheet were to completely, or even just largely, disintegrate. Other things to bear in mind are the possibilities of such melting events setting off seafloor sediment collapses, like the one thought to have caused an enormous tsunami that hit Western Europe in prehistory, and also the inevitability of large post-glacial rebound in the surrounding areas. The land rises due to the lack of compression. There are other possibilities as well, of course, but the aforementioned ones should give those who read this a better understanding of the way that ice sheet melting and cycles of regional and volcanic and tectonic activity are linked. While cycles may not show clearly on the global level when it comes to such things, they do tend to show on the regional and local levels. Support Clean Technica's work via donations on Patreon or PayPal. Or just go buy a cool t-shirt, cup, baby outfit, bag, or hoodie. Tags: Antarctica, earthquakes, East Antarctic ice sheet, East Antarctica, glaciers, global weirding, Greenland, Greenland ice sheet, ice caps, ice sheets, Iceland, Mount Erebus, sea level rise, subglacial volcanoes, tectonic events, tectonic plates, volcanic eruptions, volcanic hotspots, volcanoes, West Antarctic ice sheet, West Antarctica.